Hello, everybody. Greetings and salutations from Steve Matthews, Teeth of the Lamb. And welcome to my presentation of some preliminary data on the moon's rotation. And we're also going to talk about field rotation and equatorial mounts. The title EKG of the moon is basically because with an electrocardiogram at the doctor or hospital, they can determine valuable information about the function and operation of your heart. And in like manner, we can also learn by observing the motions and lack of motion in the rotation of the moon. We can learn valuable information about what we're actually seeing. And just like on an EKG, it's going to list your pulse, which the doctor can tell how fast your heart's beating. We're going to take a look at the moon, and we're going to take its pulse also and see what kind of activity it's doing. Is it moving at a constant rate of speed? Is it fast? Is it slow? Well, we need to determine that because that'll give us valuable information. I want to stress that when we talk about movement, we're talking about the rotation, the clockwise rotation of the face of the moon. We're not talking about the speed of its orbit, but we will be touching on that topic as well. But now I'm talking about the rotation of the face of the moon. That's what we're going to talk about today. I think that we can prove beyond a reasonable doubt that the moon indeed is actually moving. So what we see is real. And I think we can prove also that equatorial mounts work exactly like they're supposed to. They take the motion away. But we don't want to take the motion away. We want to observe the motion and see what's going on. And I think we can learn a lot by doing that. I'm going to present here just shortly what I've found and let you decide. And you can do these same tests by taking a photo every hour or so and lining them up on a table or on your computer and analyzing them. See if you come up with the same thing I do, and almost guarantee you will. So without any further introduction, let's get into the meat of it. In my chart here, what I've done is I've taken 4 different days where I've filmed the moon or taken photos of it every hour or so. These are all in chronological order by time, and starting from the left-hand side, we go over to about around noon on most of them. As the moon traverses the sky in your field of view, it appears to be moving at the appropriate speed, and the problem I see is it is not consistent in its rotation of the face. What we see on the first line, and I'm going to zoom in on it, is a rapid increase in speed in the very beginning, starting at the dark, and then it just levels out, and it looks exactly like what you'd expect to see in a field rotation situation. There appears to be a very gradual rotation of the face to the right, which is a clockwise rotation, and it just goes on until the end of this, just like that. And of course, that's what I expected to see, and I almost gave up there. Thought, well, it is a field rotation situation where it just gives the appearance of rotation. And the shadow and the moon itself are rotating simultaneously in all of these. So you can see that for yourself. I hope the quality is good enough. I've got the actual photos, but in laying them out on this sheet here, it's lost a lot of quality. So there we have the first day. And people don't like to hear this, but it kept getting dimmer and dimmer until I couldn't focus on it anymore and I lost it. But I have reason to think that it actually returned that day because it wasn't supposed to. It was about 1 o'clock and it was supposed to set at 4 o'clock, but that's something for another time. Now these aren't all time and date stamped, but they are in chronological order. My camera puts them that way automatically. But in the future, I wasn't planning on this, but in the future everything will be time and date stamped, which is better, and down lower they get that way. So here we go to day 2. That last row was from 7:30 to 2:25, and this row that we're going to look at now is from 8 o'clock until 2 o'clock. I'd like you to pay special attention to the Sea of Crises, which is near the top on the first one, and follow it around as it makes a gradual rotation to the right, clockwise, and then we get up to about between 10 and 11, and it makes a drastic jump all of a sudden. I've marked it with a red arrow to draw attention to the time between 10 and 11 where the drastic jump occurred. We have the Sea of Crises at about the 12:30 mark on the top, and it pretty much stays there. It's gradually rotating to the right clockwise. Then it gets up here to about between 10 and 11, and it makes a drastic jump in 1 hour. And then it kind of stays constant. You've got the Sea of Crises now is right almost under the green line, and then it starts moving again. So we've got a speed differential here, and that's all I can figure out. The rotation of the face is speeding up at times. I want to stress here that in field rotation, you couldn't have vast differentials in speed, speeding up and slowing down like that. The face of the moon is obviously, in an hour, moving much faster at times than it does at other times. And it's occurring at different locations in the sky. And with field rotation, you can't have that. With field rotation, it would demand that you have constant rotation across the sky, and at any given point in the sky, you should always have the same angle of the moon. Also, I want to give a special thanks to Richard, Mr. Thrive and Survive. He's been a real inspiration, and he's actually taken the time to listen to some of this stuff, and we've discussed it, and he's doing independent observations himself. He actually recorded the moon jumping slightly backwards with 2 separate equatorial mount cameras, which is impossible. When you're done here, jump over to Richard's channel, Mr. Thrive and Survive. I'll put a link in the bottom so you can subscribe to him as well. Pay close attention in day 3 here, because the shadow angle is really, really important. It's a little hard to tell without watching that, but it jumps twice. This line's a little shorter than some. It's from 7:30 to 11:30, but you noticed here at 8:30 we've got a definite angle change in the shadow, and then also at 9:30, and it's quite a little bit for 1 hour. And then it just kind of moves on the way it should. We've got some fluctuation in speed of the rotation of the face of the moon, definitely. Now we'll move on to day 4. And on this day it was particularly interesting because what it did, it stood basically motionless in the sky with my standard mount camera for about 4 hours. And then it started to gradually move, and at one point it jumps again a large amount, and that's real inconsistent. And with my camera, I'm not supposed to be getting motionless, the moon not moving. It's supposed to be constant, and so that's a problem too. Now on the 18th and the 19th, the day before the full moon, I had the moon virtually stand. The first 4 hours it stood still. The Sea of Crises is straight up on the top of the moon, and it doesn't move. I took the first and the last one and overlaid them, and you couldn't see any difference. Then we start getting a gradual move. So watch how this happens here. So we've got the moon motionless the first 4 hours with the Sea of Christ is in the exact same position. Then we get a gradual movement clockwise, but much less than on any of the other days that I've recorded it. Then right at midnight, it makes a huge jump forward. Then it starts making a clockwise rotation again, but this looks much faster than it did earlier, just after it stood still. So I don't know. We got speed problems. Our moon has tachycardia and AFib. And that orange moon off to the right at 5:45, I was able to click one more picture. It looks like it hasn't moved from the last one I did. You may not realize what this means. This means the moon actually moves. It's not caused by field rotation. Now, field rotation may play into it. I don't know, but I don't think it does. We've got the speed of the moon is variable. I'm picking it up not moving at all with my stationary non-equatorial mount camera, and that's not possible either. I want to talk for a minute about equatorial mount cameras. They're designed to not give motion. They're moving at the same rate of speed as the item they're filming. And if you mounted a camera to the tire on your car and had it filming, you would think it was stationary, not moving. And that's about all it's doing. And it's not any good indication whether or not this moon is actually rotating or not. It's actually taking it away. I have a little demonstration. My feeble little mind might oversimplify things, but this is what I see as equatorial mount camera doing. Watch this. I'm going to use a merry-go-round in my demonstration. One of the very few left in the state for sure, maybe the whole country. But let me read these titles to you. Where's the merry-go-round? Why modern playgrounds don't look like they used to. That's the title to an article. Parks, what happened to all the merry-go-rounds? Portland parks rethink old school merry-go-rounds in worry over safety and rust issues. Personally, I think they removed the merry-go-rounds because you can't have such dangerous devices in the education system. They've removed everything from all the schools. They've removed them from the parks, the cities, and anywhere they can. The only one that's left in our area, they couldn't remove it because the people fought back and they didn't have a legal right to remove it. I think they don't want some snot-nosed little kid figuring out how field rotation stuff works, so they had to remove them. This is what an equatorial mount camera sees. It sees a stationary, non-moving moon. Consider the merry-go-round a moon, and the centerpiece there, that hexagon-type shape, just consider that the moon. And so there's our stationary moon through the eyes of a equatorial mount camera. Here we are again. We're using the equatorial mount camera, and I'm standing on it. And lo and behold, I point right down at it. It's stationary. That's what this equatorial mount camera does. It moves at the same rate of speed, so you can't tell that it's moving. And we don't want to use that for nothing, because we're not going to get any data that way. And that's what they want us to use. They don't want us to see that rotation. It's all an illusion. Well, I believe my eyes. Now, this is what I see with my camera. And it looks a little bit different, doesn't it? If I went down and stood on it, I'd see the same thing that equatorial mount camera sees. I think you get the picture. That's what we see. Is it moving? Is it real? Absolutely it is. My standard mount camera, if it's all an illusion and it's field rotation causing the moon to appear to move, My camera is not supposed to get a stationary moon. I had a stationary moon for 4 hours, and I have reason to believe that if we watch it, that these things are regular occurrences. Anything that God has made keeps perfect time, and it's consistent, and it's repeatable. And I think we're going to find more of this, and I'd love everybody to start recording it. I mean, do it just like I did, and you're going to be amazed at what you find. These first 3 days that I filmed it, they were just in my library. I never knew what I had, but I went back and looked at them because I'd already done the work. I was actually watching the way the moon carries the shadow right with it. When it's rotating, the shadow's moving right along with it. It doesn't change one bit. A fixed sun shining on that, the moon would turn and the shadow wouldn't. So anyway, that's another whole problem. But there's a lot of problems. Just like anything they don't want you to look at, once you start analyzing it, it just falls to pieces. So we'll be doing more of this, at least I will, and I'm sure that Rich, Mr. Thrive and Survive, will be doing the same. He's a warrior, I'll tell you, and I appreciate him because he's very supportive. If you like what you see here, like, subscribe, and share this video, and we'll be making more of them. On the same topic probably until we get it figured out. And this is just preliminary data at this point because the weather's been so bad I can't get out and do much filming it right now. But when I can, I will, and I'll share it with everybody. So like and subscribe and share, and don't forget to run over to Rich's station and so you don't miss any of his upcoming videos. Thank you, and everybody have a darn nice day.